always like that. Okay, sorry about that. It's 5 minutes of technical difficulties. How are you, James? Are you there? I'll take that as a yes. Okay, just call me if my phone drops. All right, angels. Today I'm going to do the section called angle of inclination. All right, now you haven't seen this before, so watch carefully. Basically, if you put your pen on the positive x-axis here, and you move anti-clockwise till you hit your straight line, that is the definition of angle of inclination. So the angle of inclination, put your pen on the positive x-axis, go anti-clockwise to where you hit the line. Now, you can see that this red straight line is going to have a positive gradient. Look, it's going in that direction like a tick. So you would expect this gradient to be positive. All right? Now remember, the gradient of the straight line, we refer to y equals mx plus c. Now, you'll notice that if your gradient is positive, you see you're going to have an acute angle of inclination. That means greater than 0 degrees, but less than 90. If you look at the diagram on the right, you'll notice the straight line is going in that direction like an N. So before I even get the gradient, you will know that the gradient is going to be negative. The gradient of this line will be negative. Now, if you put your pen on the x-axis, anti-clockwise to where you hit the line, do you notice that if the gradient of the straight line is negative, your angle of inclination will be an obtuse angle. Obtuse angle meaning bigger than 90 degrees, but smaller than 180. All right, very quickly, you might want to say, I don't understand why is gradient equals to tan angle. Let me just quickly explain that to you. All right, let's pretend, lamb chops, that this is the ground floor and this is the second floor. And I think I did this one lesson. I have a vague memory trace of drawing my very bad diagram of someone in a wheelchair. Okay, sort of like that. Okay, we'll make it a girl. Okay, and the wheels would have to touch the ground. Anyways, if this person wanted to get from the first floor to the second floor, they wouldn't be able to go up any lifts. They'd need a ramp. So let's make that the ramp. All right, so they'd go from there up the ramp up. If I just extend that and drop it perpendicular down, all right? So do you agree that if this is my angle in a right angle triangle, then opposite the acute angle is the y, the vertical, and on the x-axis would be the x. So this would be my radius or hypotenuse. But do you see that tan of an acute angle, do you remember tan is the y over the x? And the y over the x, the change in the y over the change in the x is gradient. So in other words, tan of an acute angle equals to the gradient of that straight line. All right. Now, the first thing you need to do is get your gradient. So remember gradient, we tell you examiner of the line AB. Do you remember the formula where you take the difference in the y values of the coordinates divided by the difference of the x values? So you might just want to make a note, who's who. So the gradient of AB, now I know I'm going to get a positive answer. Let's see if I'm right. So I take the y of this coordinate, I'm minusing the y of the second coordinate over, now remember if you started here, you've got to start with this x value minus this x value. And remember to minus the minuses in a bracket. Okay, the gradient of the line segment AB is going to be 4 plus 2, which is 6, over 3 plus 1, which is 4. Simplify that. Remember, you have to give a ratio in its lowest form. It's positive 3 over 2. Right. So if they say determine the angle of inclination of the line AB, they don't even have to put theta in. You must just know that we're talking, that is your angle of inclination. So the formula you are given in matric, m for gradient of the straight line equals tan of the angle of inclination. So the gradient of this straight line is positive 3/2. Now remember in trig, if you're looking for an angle, this is where you always go shift. So you'll press shift 3/2. And at your angle, it will be acute because you can visually see that. So if I just take my Casio, let's just go shift 9, 3 equals AC. Let's just get on the right mode. Okay, so I'm going to go, I want the angle. So theta, the angle, you go shift tan, then go up, down, 3/2. I'm going to close my brackets, and I get an acute angle of 56,309, so 1 degrees. I will round it off to 2 dPs unless they state otherwise. So that is the angle of inclination. Now, if the gradient of the straight line is negative, you're going to get this obtuse angle. Now listen carefully to what I'm going to say. Because you know that the adjacent angles on a straight line add up to 180, I'm going to call the acute part, which would be the part of the angle on the other side. Okay, I'm going to call this acute part theta reference angle, or theta acute, this part. All right, now just keep watching what I'm going to do. I'll show you how you get the marks. Step 1 is a bit of talking. Guys, can't hear? All right, so step 1, you need to get the gradient of the straight line, and you'll get a mark for that, minimum 1 mark. So the gradient of CD, so I'm going to take the y minus the y over the matching x value minus the x value. All right, so if we've done this correctly, we're going to get minus 4 over 1 plus 1, which is 2. So my gradient of this line is negative 2. So minimum 1 mark is 2. Keep it quiet, guys. I can see the gradient is negative. Now watch carefully. If I make the gradient now positive, look, I know it's negative, but if I go gradient of a positive line equals tan, you will always get the acute angle or the reference angle. So if I make the gradient positive 2, then it's going to equals to tan of my reference angle theta on the other side. So guys, theta acute, or you could say reference angle, whichever you want to do. You're going to only plug the positive bracket. You're going to
hello.
Hi. I can hear you.
Okay, thank you very much.
The reference angle for theta is 63,43 degrees. But the actual angle of inclination must be obtuse. So can you see why I'm going to take 180 degrees minus the acute piece to give me the angle of inclination? So if I just subtract that from 180, the angle of inclination of a negative gradient will be obtuse, and it's going to be 116,57. Now, there are different ways to do the negative obtuse angle, but I'm just going to say again, on the other side of your angle of inclination, I normally call it theta acute. I won't lie, I don't have a reference angle. Theta acute is part of the angle. So we know 1 or 2 marks done. But then, if the gradient is negative, make your gradient positive and say that equals to, let's go tan theta acute. I think that's much cuter. Excuse the pun. Okay, so theta acute. So we're going to go make the gradient positive. We get the acute angle, which is the one on the left, and 180 minus that angle will give us the real angle of inclination. All right, let's try another one.
Ma'am?
Yes?
How did you get the 63, comma 43 degrees?
Okay,
Like,
so
what did you
you know the
test
gradient.
on your calculator?
Okay, remember the gradient was -2? So I
Yes.
made the gradient positive. So you go shift tan 2, and you will get the acute angle. Because look, you're looking
Oh,
for that. So the actual theta, you're going 180 minus theta acute. So the actual angle of 180 degrees minus the 63,43. Remember, whenever you're looking for an angle, you press shift tan 2, and then you will get the 116,57 degrees. Does it make sense, Laptop?
yes, it does. Thank you, ma'am.
Okay, cool. Let's do another one. I will give you these exact 2 examples. The one I'm going to do now, I might or might not give you because I'm just going to make it up. So I'm making up 2 random examples. And then I'll show you how to ask this a little bit harder. Okay. So let's see, guys. Watch. Please don't talk. Watch. This time, that's my x-axis. This is my y-axis. I'm going to say the equation is y equals to, can you hear me? Minus x plus 1. Now, I'm giving you the equation of this straight line graph. Should I call it graph F? Then I would replace the y and say the straight line graph f of x equals to, there it is. It's in the form of a straight line graph, y equals to mx plus c. Now, if the examiner said determine the angle of inclination, determine the angle of inclination. They would just say of the line, and then they'd either give you the letters or they'd say of f of x equals to minus x plus 1. Now, we know angle of inclination, we know that you put your pen on the positive x-axis, go anti-clockwise to where you hit the line. That is what they're asking me to find, the angle of inclination. Now, the formula goes gradient of the straight line equals to tan of the acute angle, all right? So just remember, this is always the acute angle if the gradient's positive. Now, do you agree that the gradient of this line, can you see, is the coefficient of your x to the 1? So the gradient is minus 1. Now, I know the gradient is minus 1. My angle of inclination is going to be bigger than 90, but smaller than 180. So you will notice in my diagram, I will put theta acute on the other straight line, because that's an acute angle degree. The angle of inclination is an obtuse angle. Can you see it? All right. So what I do is I make the gradient positive, and I tell my examiner that equals to tan, but then you must go theta acute on the other side. Now, when you're looking for an angle, remember, theta acute is no longer tan. Look, it's just theta acute. Do you understand? You're going shift tan 1 equals. You will get 45 degrees. So this acute angle is 45. So the angle of inclination will be 180 degrees minus that acute angle, which is therefore an obtuse angle of 135 degrees. All right? Let's look at one more example. Let's make it a positive gradient. Let's say this is the straight line h of x, and it equals to, let's just go a half plus 1. Okay, not drawn to scale at all. There's my x-axis, there's my y-axis. If they say determine the angle of inclination of h, we know we're referring to this angle here. All right, that is your angle of inclination. I hear a lot of music in the background.
This was over funny.
Am I trying to like, okay, I'm not going to do this to a song, but now positive gradient. So we know that the angle of inclination is going to be acute.
Lovely,
Gradient
lovely.
is positive a half. Do you see why the gradient is positive a half? Equals to tan. Now, because of the acute inclination, you can see I'm cute. Okay? So we're going to go shift half. Let's do that. Shift tan 0.5 equals angle of inclination theta 26,565 degrees. So just to show you how to round off degree, that's 26,57 degrees. Okay, I know the students find the negative gradient harder, so I'm just going to one more for the negative gradient, and then I'll show you how I can ask this in a higher form. So let's go put my axes. Guys, it's a little bit noisy on your end.
Ma'am?
Hearing a lot of noise. All right, let's just draw you. This is point A. Let's pretend x is minus 3, y is 2. And let's make this point B where x is 1 and let's say y is minus 4.
Ma'am?
Right. Guys, I can't hear. Shush. If they
Ma'am?
want the angle of inclination, do you see it's that obtuse angle? Are you calling me, Angel?
Ma'am?
No. Yeah?
Is M always
It's always tan, yes. Gradient of the straight line equals tan of the angle. Always tan. Remember why? Do you remember I showed you, if you're looking at this straight line here, just for example, all right? Do you agree that angle there, which if that's the x-axis is angle of inclination, do you agree that is the y, is the x? Another way of writing this is tan of theta, do you agree, equals to the y over the x. But we know that the gradient of the straight line is the change in the vertical over the change in the horizontal. So because gradient of the straight line is the direction and the we travel vertically, which is the y, divided by the direction and the distance you go horizontally, then you will see why it will always be tan, y over x, y over x. Okay, very quickly, let's get the gradient of the line AB. So we take the y of the one minus the y of the other over x of the matching coordinate. So let's go to y minus 4 minus this y, which is 2, over 1 minus 3. So minus 4 minus 2. Okay, guys, there's more music there. I'm not doing this too. Okay. Minus 4 minus 2 minus 6. Over 1 plus 3 is going to be 4. Can I simplify that? Yes. Minus 3 over 2. Now you can see the gradient is like an M. So the gradient you can see is negative. So you know your angle of inclination is going to be bigger than 90, smaller than 180. It's going to be obtuse. But remember, this is theta acute on the other side of the straight line. How do you get theta acute? Theta acute is tan. Just make, sorry, that's, the gradient equals to tan theta, okay? Now, if I make my gradient positive, no, positive 3 over 2, despite the fact it's negative, then that will find you theta, tan of theta acute. It will find you the acute angle on the other side. So you make sure your examiner knows you know what the real gradient is. Then as long as you make it positive and say that tan theta acute, then theta acute which is, this is not your angle of inclination, that is the angle of inclination. So I've got to first go shift, wait, let me just, it's in the wrong mode. So I'm going to go shift 9, 3 equals all clear. Okay, now it's back to degrees and maths. So we're going to go shift tan, ratio up, down, 3/2. Notice I made it positive gradient. By doing that, I get this acute angle here, which is 309, so make it 3:1. So the angle of inclination, this theta, the angle of inclination, which is theta, this theta. Do you understand why you're going to go as 180 degrees minus the acute angle on the other side? And that is how we're going to get our answer. So if I plug that in my calculator, it's 123,69 degrees. Remember your degrees sign. Okay, so that is what this is all about. You wouldn't have done 10, only in grade 11. But let me kind of show you how they're going to ask it. The probability you're going to get asked something like the following. So just watch. One of two case scenarios. Case scenario 1, let's say they have the y-axis. Let's say we have the x-axis. Let's say we have a straight line, like so. I'll give you the equation of the straight line, okay? So let's pretend the equation. So let's pretend the gradient is 3x plus 2. That, I'm giving you the equation of this line. And that is theta. And they're going to ask you of now, please take note of your angle of inclination of this line. You put your pen there to there, it's still an acute. By gradient positive 3. So because gradient of a straight line equals tan of the angle of inclination, I have to use a beta, not theta here. So the gradient is 3 equals to tan beta. Now, lamb chops, once I've solved for beta, you know that your axes intersect at 90. So I can use sum of angles in a triangle because that of inclination would equals to 180 minus the third angle, sum angles triangle. All right, so the first thing I must do is get angle B. So I'm going to go shift tan 3. So angle beta is going to be 71,565 degrees. I'm just showing you so you can get your rounding off correctly. So do you understand this angle is acute? I would expect it's an acute angle, look, because the gradient is positive. But if they want this theta, then do you agree? I know that if I subtract 90 degrees, the acute angle there is theta will be 18,43 degrees because sum of angles in this little triangle here. To prove it to you, if I take that angle, which is 90 there, I add beta, which is 71,57 equals, and then I subtract that from here. That theta is 18,343 degrees. Now that's still quite easy. So before we end today's lesson, I'll show you what they're going to do as hard as it can get. And it's really not hard. It's actually a lovely, lovely section, this, I promise you. So let's say, here are my axes. There's my x-axis, there's my y-axis. This is going to be in the note I give you. The one straight line is going to cut the y-axis there at 0 and 3. And that line is going to cut the x-axis there at point D, which is 1, 0. And that was point A. So there's my one straight line. So I'm just going to draw it. At the line F. All right? Sorry. Remember, Mike, if you miss the point, make the point. The important thing in life is to make your point. Okay, so that point is 0 and 3. All right, then I'm going to give you another straight line. And this time it's going to cut the y-axis at 1. So that is what I'm calling F. So x is 0, y is 1. And this line will go through point E, not drawn to scale, guys, but it's going to be -2 and 0. So this is going to be a green straight line. Now let's just call this line G. Make the dot bigger. Right, it's a very, very common thing that they might ask you, I'm just going to use black, to find this angle here. Now notice the angle they want is off the triangle. It's not, off the x-axis, sorry, it's not on the x-axis. It's in a triangle. Find a triangle. Do you see we have a triangle? Right, now let's get a plan. Call this in your diagram beta. You can see by the way it's going, the gradient will be negative. So you can see that angle is going to be obtuse. We'll get it now. Now, that you're going to use the angle of inclination. So in other words, the gradient of the red straight line AD is going to equals to tan of beta. But remember, we will get the gradient, we'll make it negative, the gradient positive, and get this angle and go 180 minus to get the angle of inclination. So let's quickly do that. Now guys, if this is 3, look, the rise is 3, the run is 1. So rise over run, 3 over 1, but it's a negative. So the gradient's -3 over 1. If you can't do what I'm doing, just do the gradient of AD, take it slower, y minus y over x minus x. You will get, look, there's the gradient. That equals tan beta. Beta acute on the other side. Do you understand? We'll just make the gradient positive. So I'm just going to go shift tan 3, and I'll get beta acute to 71,565. So there. So beta, according to my diagram, this here is angle beta, this obtuse angle here. We will go 180 minus the 71,57. So beta is going to be 108,43 degrees. Okay. Now, if I call this alpha, remember, do not call this theta because theta is sitting there. Let's first get the gradient of the straight line. So the gradient of EF, I can see it's positive 1 over 2, but I'll just do it slower. So take the y minus the y over the x minus the x, and you'll get 1 over 2. It's positive. So a half gradient of the straight line equals tan of angle of inclination, which is going to be acute. So go shift tan a half. So this angle of inclination alpha is going to be 26,57 degrees. Now, I know the bell's going, but watch this. If this red angle here is 108,43, and this little green angle is 26,57. Do you agree that in this triangle here, your exterior angle, and that angle equals the sum of the opposite two interior angles? So theta is going to be that obtuse angle minus that acute angle. So if I plug in my 108,43 and subtract my acute angle of 26,57, 8,43 minus 26, then this theta is going to be 81,86 degrees, and you can write the exterior angle of triangle. It's triangle, there's no letter there, but if I did make that, let's say a T, it's triangle TED. So the normal of angle is when you're looking between the x-axis and a straight line. But as hard as it can get, they move the angle up or down. So it's no longer on the x-axis. But then using angle of inclination and using either exterior angle or sum of angles in a triangle, we can always find the angle we are looking for. All right, so what I'm going to do, I'm going to send you this note now, okay? It's got a positive gradient and negative gradient, and I'm showing you what to do. The example I've just done here is, sure. Oh, I asked you to find this angle, not angle. So just for interest to make sure I did it right before the bell goes, if I go 100, where did I get theta there? 180 minus this theta, which is 81,86. Then this angle would be 98,17, which is correct, okay? In my example, I found that angle, not that angle, but I'm sure you can work it out for yourself. Just look at the diagram and you will see that I've actually worked this angle out. So using that exterior angle, you can get this angle and then just subtract it by 180. All right, and then on this side, I'm giving you another case scenario. I'm just giving you the answer to 1 dp, and just make sure you get the hang of that. Then I'll put it all together in our lesson for tomorrow. So your only homework is to go over this page that I'll send you. Okay, chickens, hopefully tomorrow we won't have such bad technology. Love you lots. Keep safe.